Malte is joining us from Technische Universität Braunschweig, like also the T-shirt already says, and if he's not just participating in Hacker Jeopardy, then he is researching web security vulnerabilities, and not just in the web, but also on the servers. So let's give a warm round of applause for Malte and enjoy.
Yeah, thank you. This is a server-side request forgery, attacks, defense, and status quo. As already said, I'm Malte Wessels. I'm a PhD student at the Institute for Application Security at TU Braunschweig, and I also do some privacy at the German privacy NGO Datenanfragen.de and play some CTF with the best team, Cyber Task Force Zero. So feel free to talk with me about that. So imagine sending a link to a nice kitten pic in your favorite instant messaging application. You most likely get like a little link preview, right? For this example, I sent like an Unsplash link, and in this case, Matrix previews me a picture of the kitten and a nice title and a description text. And this is like a typical use case for server-side requests, but there are plenty of others. For example, webhooks in your GitHub or GitLab, or just APIs on the server side in general. And this would look something like this. Your client is requesting the chat server and says, hey, I need a preview for this URL, in this case, unsplash.com/something. Then the chat server goes ahead and fetches that resource from the remote server, so in this case, Unsplash. Unsplash returns the kitten pic, and the chat server forwards it to you as a client. And this right-hand side is called a server-side request, because the server is requesting something for you, just like the client, but the server. But this can go wrong. And the typical example would be to request localhost. So if the client asks the server to, hey, please give me something, here's the URL, but the URL is localhost, the server will try to fetch something from itself. Most probably something that's not intended to be fetched from the outside. And there are like plenty of examples how this can go wrong. For example, there could be like internal resources, or you could have like a whole intranet. So you'd most likely have like an internet which is not available from the outside. So if an attacker wants to access your database or something in the intranet, the firewall won't let them through. But of course, the firewall will let them through to your web server, because people are supposed to go on your website. But if your web server is vulnerable to server-side request forgery, people can misuse your web server to access the intranet, return the data, and pass it through to the web server again to you. So using the application as a proxy, so to say. And from the point of view of the firewall, this is totally okay, because communicating with the web server is totally fine. So what can we do against this? If we are in the allow listing case, so if we know that we can trust a certain number of hosts, and we trust only those, and we only want to request those, we can just compile a list and check the input against that list of trusted hosts, and then we're basically done. We should just make sure that we're only using one good URL parser to avoid parser confusion attacks. And we can just compare that host against this list, and we're done. But this is not applicable for most use cases. For example, the link preview case. You want to generate link previews for all possible links, not just a handful full of hosts, right? So we need something called deny listing here, where we just know that certain hosts are undesired, for example, localhost, and we want to block these. So you might come up with, yeah, okay, we can do like a string-based defense. We could like check if the string input, the URL, contains the string localhost. But that doesn't work, because an attacker could just use the IP directly, right? The loopback IP. I could also check for that loopback IP, but then the attacker could go ahead and encode it differently. That still works. The attacker could also use Unicode. So for example, which I find really funny, is this Unicode character, which is like 7 in a circle. And if you put that into your, for example, curl client in PHP, I'm curling this loopback IP, but the 7 is replaced with the 7 in a circle in Unicode. The curl client just goes ahead and fetches that request from localhost. I think this is totally spec compliant, so it's not curl's fault here, it's just how things work. So you can't possibly defend on the string level. So you could go ahead and do the same thing as in the low listing case, we could go with the host. So we can just take the URL from the user, pass the host out of it, and compare it against a list of known bad hosts, for example, localhost. If it's in the list, we stop. And otherwise, we conduct the server-side request. But what does conducting this request actually mean? It means that we have to take the host part of the URL, resolve it to an IP address, and then we conduct the request against that IP address, because that's just how networks work, right? So we have a certain mismatch here. We are checking against a list of hosts, but we are requesting against an IP address. And that means an attacker could go ahead and register like a new URL, or use like a funny URL. For example, which I really like is fbi.com, which resolves the local host. And you might have known that, and you might have included that in your block list, but you probably didn't. And even if you did, an attacker could just go ahead and register a new host on the fly. So that's not really feasible as well, right? So the fix is maybe to use DNS ourselves. So instead of just passing the host, we pass the host from the input and then resolve it against an IP address and compare it against a list of blocked IPs. So for example, the loopback IP. If it's in this list, we stop again, and otherwise we conduct the request. But again, what does conducting the request mean? We take the URL, resolve it, and make a request against the IP address. And we are resolving it twice now. And there's a certain slight but existing time-based difference here. So we have like a time of check to time of use situation here. This means that an attacker could go ahead and configure a DNS server to rapidly switch between two IPs for the same domain, and with a very short time to live. That means if I'm resolving this domain once, I get the one IP, and if I'm resolving it a second time, a second later, I get the second IP. And if the attacker tries it for a bit, they will pass the first check, but then get back to a banned IP, so localhost, in the second step. And there are services available for this. So the solution for this is DNS pinning. So we take the IP, compare it against the list, and then reuse that specific IP in the actual request. And this is like the only way to defend against server-side request forgery in the deny listing case. And my point is, this is pretty complex and not intuitive. So we're wondering, while doing research, this is pretty complex. Are people doing this correctly? And this is where our study starts. So we're looking at PHP, because PHP still powers most of the web, and we pulled 30,000 repositories from GitHub. We also looked at the PHP ecosystem. So for example, there are several frameworks that support server-side requests, but out of them, only Symfony provides like a defense against this attack. And we also looked at HTTP clients in PHP. And there are several, for example, curl, but only the family which is pretty obscure of safe curl clients, which, as the name implies, are like a replacement for curl, and they defend against this. So we wondered, we have these 30,000 repositories from GitHub. Are people actually using these safer alternatives? 4 repositories were using them. And out of these 4, 1 was maintained by the same person as the safe curl thingy. So in reality, like only 3 third-party applications are using like a off-the-shelf defense. Okay, so if people are not using the available off-the-shelf defenses, maybe they're doing their own stuff and building all this complex stuff, we think. So we conducted a static data flow analysis. We did our own pipeline and took some PHP source code and built like a fancy graph out of it, and then we can check for data flows on that graph. And then we took these results for possible vulnerable flows for server-side request forgery and looked at them manually to see if there are any defenses. So maybe if people are doing that on their own. And we found that 2 applications do it properly on our data set. And they are both in the allow listing case, and no application is trying to do DNS resolution whatsoever, which is like required for a proper deny listing approach. So like as a little conclusion, I can say that like we as a research community, especially OWASP, which has like great resources on SSRF, we are pretty aware of the risks and the solutions, but developers get it wrong. And to give you some practical takeaways, if you're ever in the situation you have to implement a feature like this, you have to think of compiling a solid list. So either in the low listing case, compile a solid list of trusted hosts, or a solid list of things you really don't want them to request. So probably everything on your local network, or maybe in the cloud. If you're in the low listing case, you're pretty secure. And if you're in the deny listing case, you have to think of all the stuff we just talked about. So you have to use DNS or IP pinning. And we also didn't talk about a lot of other stuff you have to think about. So, for example, you have to configure your HTTP clients properly. Because, for example, if they're following redirection, you need to think of all these checks for each redirection step. Or you just disable redirection. And you also have to think about protocols. You probably only want them to request HTTP, but there are ways where you can just bridge the protocol and suddenly the request from the server writes an email, which is not really desired behavior. And you could also think about like network segmentation. Yeah, that was my talk. Thank you very much. There are my contact information.